In this lesson, we shall focus on calculus, which pertains limits. Right, so let us get started with calculus and discuss limits. Right, to start with, here is a question that says evaluate the following limits and justify each step. Okay, this is just one question, but there are many other questions that we'll come across. Okay, and obviously we're just practicing on limits. Let us look at this one. How do we find the answer to this one? What would you suggest we do?
Substitute.
Substitute, you take the limit as x approaches 5, right? So we have 2 times 5, we square that, minus 3 times 5 plus 4, and this equals 2. 5 squared is what? It's exactly 25 minus 15 plus 4. What is 2 by 25?
50.
50 minus 15 plus 4. What is 50? What is 50 minus 15? Mm-hmm. Is it 35? Okay.
Minus plus 4 is
Plus 4, which is exactly what? 39. It appears that it is 39, correct? Okay, yeah, I'm sure you can do that. But also, our calculator is always often very ready at our disposal to confirm the results. Like here it is. Let us do this. Now, if you have here, we can say 2 times 5 squared minus 3 times 5 plus 4, and it is 39. So we got 39, right? So 39, yeah, we got 39. Okay, and the 39 is therefore the correct answer. Okay, right. We started with something easy. Something easy. Okay, let's move on to something next. Evaluate the following limits and justify your answer. Right, first and foremost, to evaluate this limit, what would you do first? I tease you. I know that you did not study all the things, but okay, first things first, when it comes to limits, we first perform substitution. We first substitute always all together and see if there's a problem. So now, but here I know that there are like too many things you can do. -1, all divided by 5 minus 3. 5 minus 3 minus 2. Okay, if you cube -3, what you get? You get -8. Okay, you square -2, you get a 4 times 2, which gives us 8. -1. You divide by 5 plus 6, which is exactly what? 11.
11.
Okay. And therefore, the answer is -1 over.
11.
Okay, but we can see that -1 over 11 has no problem. So, yeah, we're okay with this. And it is certainly the correct answer to this question. Any problem with this? Okay. Simultaneously, you can always take your calculator. Here is our calculator. And with our calculator here, we compute this. And with the calculator, we're going to take the calculator, for instance, and let's first just do this. So we're just confirming our results. So you have, for example, a -2, close the bracket, and you cube it. Right, and if you cube it like that, and then I know that mostly you don't even use a calculator in most of these exams. You're not allowed.
Yeah.
You're not allowed to bring calculators in the exam. Are you allowed? I know.
No, we are not allowed.
Okay, yeah, because before they used not to allow calculators because they just want to test your ability to even add the numbers. All right, so which is okay. Okay, never mind that. Never mind that. Okay, just need to did not square this one. Need to square this one. Let's see. Okay, so clearly the answer is what? Clearly the answer is exactly minus 1 over 11, and it is indeed the correct answer we got. All right, so yeah, we're good. We're good. Any question?
No.
No question. We proceed to the next one. We need to find this limit. What do we do first? What do you suggest we do? Because first I engage you. You'll forgive me because yeah. But you see, I'm talking to you only. You're the only person on the line. Yes. What would you suggest we do here before we do it together? All right, substitute. All right, substitute. Okay, so we're gonna substitute first and see if there's a problem. Okay, if there's a problem, then we find a way to deal with it. So if we substitute, we have the square root of 0 squared plus 9 minus 3 all divided by 0 squared. And now you have the 0 squared plus 9, which gives us a 9. The square root of 9 is 3 minus 3 over 0 because 0 squared is a 0, and this is 0 out of 0. Okay, so 0 out of 0, what is 0 out of 0? I'm just teasing you. I want to see what you know. I want to know. 0 divided by 0, what is it?
0.
Never mind that. Never mind. I'm teasing you because it's called the indeterminate.
Oh.
Indeterminate form. I'm going to tease you. Okay, or you can say it is undefined. Okay, because there's no definition for this in mathematics. You know, so 0 over 0 is not known what it is. Okay. Now, because now if we substitute straight away, we're getting 0 over 0, which is an indeterminate form. What do? We proceed to rationalize. Okay, so we proceed to what? To rationalize. How do we rationalize? Right, to rationalize, we take the limit as t approaches 0 of the square root of t squared plus 9 minus 3 divided by t squared. T squared plus 9 plus 3 divided by the square root of t squared plus 9 plus 3. Okay. And then now this is exactly what we're getting. And therefore this becomes the limit as t approaches 0. Right, so if we multiply by what we call the conjugate. Multiply by the conjugate. If you multiply the square root by the square root, you get t squared plus 9 minus 9 divided by t squared, which is the square root of t squared plus 9 plus 3. Okay. Okay, so we continue. Okay, yeah, right. So we take the limit as t approaches 0. 9 minus 9 is what? Is 0. Giving us exactly t squared divided by t squared, open bracket, t squared plus 9 plus 3. Okay, so this guy cancels this guy. So t squared cancels t squared, giving us 1 divided by the square root of t squared plus 9 plus 3. We take the limit as t approaches 0, which is exactly 0 squared plus 9 plus 3, which is 1 divided by the square root of 9, because 0 squared plus 9 is like 9. Square root of 9 is 3 plus 3. What is 3 plus 3 in the denominator?
6.
6. Well done. Thank you so much. Thank you so much there, Atlehan. So that this is 1 out of 6. 1 out of 6. So 1 out of 6 is the answer. What is your question here? If you would like to ask a question, what question would that be here? And if you'd like us to explain something, maybe you're seeing an error somewhere. Right, so you can talk to me about it. Any question, if you have, or any suggestion, because you can be like, okay, I can do it differently. I just suggested us using this method, right? So what would you suggest to do? I mean, you might suggest that we do it differently. Okay.
No, I don't have any suggestion.
No suggestion.
Mm-hmm.
Okay. Please note that this lesson is recorded for control and quality purposes. Because
Mm-hmm.
if the recording, then it means that you'd get the recording at the end of our discussion, and the quality of the sound and the audio will be the most perfect. Will be the most perfect. Right. Right. Okay, we continue. Right, we need to prove that this limit does not exist. I'm giving you 2 minutes to try this limit, and then we shall do it together, like 2 minutes. And then here, you will let me know as soon as you're done. All right. You let me know as soon as you're done.
Okay.
Are you able to see the question?
Yes, I'm able to see the question.
Okay, thank you. Right, so please let me know when you're done. Right, please let me know when you're done. Okay. Right. Right. So you will let me know when you're done. And then we shall do it together. And then we shall do this question together and see what we can do here. See what we can do here. And see what we can do here.
Okay, I'm done.
What answer did you get?
I got
Mhm.
-1 and 1.
You got -1 and 1. And then obviously now having got -1 and 1, what is your conclusion?
Since the limit from the left and the limit from the right are not the same, the limit does not exist.
Excellent stuff. Well done. I mean, that's good news. Thank you so much, Atlehang. Right, so obvious at this point, we need to prove that this limit does not exist. So we take note of the fact that the modulus of x is defined as x. If x is greater or equal to 0, it is minus x if x is negative. All right. And this means that we actually have two limits, so we need to consider two cases. If x is greater or equal to 0, it would mean, therefore, we need to evaluate this limit as x approaches 0, and we have the modulus or the absolute value of x over x. This is the limit as x approaches 0. What is the absolute value of x? If x greater or equal to 0, the absolute value of x is just x out of x, and this becomes the limit as x approaches 0, and we have 1 out of 1, which is 1. The limit of a constant is the constant of the limit. So if x is negative, so with x approaches 0. Okay, if this is negative. Okay, if x is negative, then we consider the sort of bottom case, because if x is negative, then you'd have that the modulus of x is just minus x over x. What is minus x over x? Is minus
-1.
1. The limit is minus 1. So now, I mean, we compare these two guys. The limits, we're getting 1 minus 1. So these two limits are different, right? So obviously, if x is bigger than 0, we actually are looking at the limit as x approaches 0 from the right, and this one is from the left. Right, so obviously the conclusion is therefore that hence the limit as x approaches 0 from the right of the modulus is not equal to the limit as x approaches 0 from the left. Okay, so these limits are not equal to each other because 1 and -1 are not equal to each other, which implies that the limit as x approaches 0 of the modulus does not exist. It does not what? It does not exist. Yeah, any comment on this one? Any suggestion or anything you would like us to change here?
No.
No, thank you so much, Atlehang. We'll continue to the next one. Okay, this one obviously is going to be as well an example, but first we practice with it together. We share some ideas on it. If f of x equals the brace, the open brace, and you have here the square root of x minus 1 under this x minus 4 under the square root if x is greater than 4 strictly. X is strictly greater than 4, but f of x, or in other words, the function is this or the bottom part. So this is called a piecewise function, given a piecewise function. And yeah, having this piecewise function, we have the following. Right, so if it is 8 minus 2x, if x is negative, determine whether this limit exists. I'm giving you 2 minutes and then we'll do it together. Just scribble, yeah, and tell me what your answer is going to be. And then we're going to do it together. Okay, you just let me know as soon as you're done. And then we're going to do it together and see what we can do here. And see what you can do here. And see exactly what we ought to do here. And see what we ought to do here. Right, so now let us know what you have here. All right.
I'm done.
Please come again. You're done. What answer did you get, Atlehang?
I got 0 and 0.
0 and 0. And therefore, because you got 0 and 0, what is your conclusion about the limit?
The limit exists.
The limit exists. And if it exists, it is equal to what?
It is equal to 0.
It's equal to 0. Well done. It's equal to 0. Thank you so much. Okay. If the function f of x is this, determine whether this limit exists. So what we're going to do now to do this limit, we're going to do evaluate the limit as x approaches 4 from the left. The limit as x approaches 4 from the left. So from the left is when x is less than 4, and the limit is x minus 2x. Right, so in which case, therefore, okay, there are two notations. I mean, do you use this notation at your school, or you use this other notation here when x approaches 4 from the bottom or from the top, because there is that notation. So when x approaches 4 from the left, somebody can always say x approaches 4 from the bottom. Which one to use? The top one or the bottom one?
Use the first one where you say the limit, yeah, with the minus on top.
All right, okay, that's fine, Atlehang. 8 minus 2 by 4, which is 8 minus 2 by 4 is what? Is 8. What is 8 minus 8? 0. And then we're going to do the other one from the right. So x approaches 4 from the right of the function f of x. Okay, from the right is this one. Okay, so which is exactly 4 minus 4, which is the square root of 0. The square root of 0 is what? Is 0. Okay, hence x approaches 4 from the left of f of x is actually equal to the limit as x approaches 4 from the right of f of x, which therefore implies that the limit as x approaches 4 of f of x, this limit is equal to what? It's equal to 0. All right, do you have a question? Or
No.
suggestion? Okay, you have no suggestion because you can look at this and be like, I have a suggestion because maybe I think, what would you like us to add? Or what would you like us to remove from this? Anything?
No.
Nothing.
Mm-hmm.
All right, good. So we proceed to the next question then. We proceed to the very next question. So let's look at the next one. Okay, this one is going to be our example. One of our examples, example 10. Don't worry about the example number. Right, the greatest integer function is defined as, right, I want us to discuss the greatest integer function is defined by the greatest integer function of x equals the largest integer less than or equal to x. Largest integer less than or equal to x. For instance, the greatest integer function of 4 is 4 because the largest integer less than or equal to 4 is 4. Here, in the case of 4.8, the greatest integer less than or equal to 4.8. Okay, can do this on a number line like this. If you put 4.8 here, right, and then if you put 4.8 here, you put 4 here, you put 5 here. This is a number line. Now, if you have the 4.8, now you are looking for the largest integer less than or equal to, so the largest integer less than or equal to 4.8 is what?
4.
It's 4. Because 4 is the integer less than, which is the largest integer, smaller than or equal to 4.8. It's 4. So the answer is 4 here. Now, we are looking at pi. So we're looking at the greatest integer function of pi, excuse. Right, so if you are to look at pi, for example, you'd use a calculator and let's just launch our calculator here and do some little bit of practice. Let's do some little bit of practice. Okay, now, for example, if you have the following, right, so we have this and we press on, and then now we want pi here on the calculator, and we are looking at this calculator very, very carefully. We're looking for pi. Here it is. Okay. Right. So here is pi, and we want to see the answer. Okay. So pi, according to this calculator, is, let's just take it to 2 decimal places, 3.14. 3.14. Right. So we come here and we put 3.14. What is the greatest integer less than or equal to 3.14?
3.
Right, it is exactly 3. And hence the answer is 3. Okay, good. And we can see the rest of this. Okay, let us look at a negative number, like -1/2. Okay, so if you have this one, okay, the integer that is less than or equal to -1/2. What is that integer?
-1.
It is exactly -1. It is exactly -1 because you have 0 here, for example, 0 there, and you have -1 there. So the integer less than or equal to -1/2 It's actually -1 that is less, that is smaller than -1/2. It's the greatest one. It's smaller than -1/2. Okay, let's look at this question. So now, okay, let's look at this one here. With this in mind, can you evaluate this one? Let me do it in red. Right, so now I want us to try this one here. I want us to try this one, do it in red. Okay, if you have, for example, the limit as x approaches 3 of this. What is this limit here?
3.
Okay, you're able to see the limits. Okay, never mind. So we'll get that together. Okay, you think the limit is 3. Why would you think it's 3, Akhihan? We're just talking before we're going to do it together. Why would you think it's 3?
The integer less or equals to the limit is 3.
Okay, that's fine. So now, first and foremost, we need to identify x equals 3 here. And x equals 3 is this one, correct? If x equals 3 is this one, we need to look at what happens when x approaches 3 from the left of 3. But also, we're going to look at the limit as x approaches 3 from the right of 3. Okay. So if you look at it carefully, when x approaches 3 from the left, okay, yeah, when x approaches 3 from the left of 3, what do we get? Okay, because here is 3, but from the left of 3, and the 3 is here, from the left of 3, the function itself is actually equal to 2. Right. So in other words, as x approaches 3 from the left, clearly we are able to see that now from the left means you can actually do this. So as x lies between because now from the left of 3 would be 2. That is the next integer. So you would take that at this point, what you have 2. And also, you actually have 3. So now at this point, you have that your x sort of varies there. But also you're able to see that at this point, the function accepts 2. Accepts 2, but obviously we are going to the left of 3. Now, from the right, as x approaches 3 from the right of 3, so it means that you are looking at this part. So we are looking at x between 3 and 4 altogether. Okay, so now you can see that you can take the 3 because the function there actually is 3 is defined, that is, at at 3 because it is exactly 3. So now, when x is less than 3, the function is 2. Okay, when x is bigger than 3, the function is 3. When x is bigger than 3, the function is 3. When x is smaller, the function is 2. Okay, so this realization is very, very crucial. Hence, we're able to see that the limit as x approaches 3 from the left is not equal to the limit as x approaches 3 from the right. Hence, the limit as x approaches 3, this limit here does not exist because the left and the right hand limits are different. The left and right hand limits are different. Any question on this one, Atlehang? And obviously, I mean, it's very easy for a student to just think that the limit is 3 because they just put 3 there. So the student can say they just substitute 3, but we know that this is a stepwise function. So this is the graph of the greatest integer function. So if you analyze the graph, let's spend a minute or so on the graph and interpret the graph. But what is very key about this graph is the fact that if you look here, whenever x is 0, the function is 0. Whenever x is 1, the function is also 1. Okay, so at 1, it is not here, it is 1 there. It is not 0, but it is 1. That's why it is open here. But whenever x is 1/2, okay, the greatest integer of 1/2, what is the greatest integer of 1/2? The integer that is less or equal to 1/2. What do you think the one is, Atahan? Okay, so it is 0 and then 1. So now the greatest integer, now you must draw a number line. And then now look at the integer, largest integer that is less than or equal to x. So the largest integer that is less than, what is the integer that is smaller than 1/2? The integer is this one. It is 0. So that is why, therefore, this one is what? Is 0, because the integer is 0 there. Right, so obviously whenever x is 1/2 here, the function is also 0. So it is indeed here, but obviously it is open there. And whenever the x is 1, the function is 1. But you see, whenever x is 2 right now, what we're able to see is that this function at 2, it is also 2. So it is not 1. So this is like open one. But let's look at 1/2. 1.5. Like here at this point is like 1.5. You agree? 1.5. Okay, at 1.5, what will the greatest integer function of 1.5 be? What do you think that one is, Atlehang? The greatest integer is less than the number that is like an integer, a counting number that is less than or equal to x. What would it, in this case, less than or equal to 1.5. What is it?
1.
It is 1. Excellent. So that is why at 1.5 here, the function becomes 1. So this is the stepwise function. You can graph it like that. You can go to the negatives and you can go to the positives. Let's continue and try more problems. This was just a brief talk about the greatest integer function. And now there's something called the ceiling function. We're going to discuss these kinds of functions. Let us find the following limits. Can I give you 45 and you try it? Okay, please, yeah, I'm giving you like a minute and then please let me know when you're done. Please let me know when you're done. Right. So please let us know when you're done.
So I'm your host for the Big Morning Chat Show, every Monday to Friday between 9 to 12. So let's start on a Wednesday, which are 26. I just want to put it out there, which I'm not going to be able to make it to the show because I'm not feeling too well. But Umioza is going to be standing in for me until I become fine. Hopefully tomorrow, with a little bit of medication here and there, I'm going to be fine. Otherwise, do tune in. It's a jam-packed show. First hour, classic 9 at 9. List request.
I'm done.
You're done. What's the answer?
5/3.
5/3. Okay, good. Let's just try it together. So you have the limit as x approaches 0 of the sine of 5x divided by 3x. The limit as x approaches 0. Right, obviously, I mean, you really are on point here because what we're able to see is we want this to be 5x over 5x. Okay, obviously, I'm going to find out what you actually did there. The 3 cancels giving us that. Okay, so now, so you have 5x, 5x. So you have the limit as x approaches. Okay, so at this point, you can, because we just introduced the 5, and this 5 here is like this 5 cancels this. So it's still like the same thing. So now if you have 3 out of 5, you have the limit is x. Okay, so you can put 5x, because as x approaches 5, you can multiply by 5. Here, multiply by 5 there, 5 by 0. And then obviously it is still 5x approaches 0, which is exactly sine of 5x over 5x. And this limit is a 1, this one, because it's the same as the limit of sine theta out of theta as theta approaches 0, theta, please. Okay, so obviously at this point, we agree that this is exactly theta approaches 0, and this limit is 1. Okay, so obviously this is like 3 out of 5 by 1, which is what? 3 out of 5. Okay, any question?
No.
No question. Okay, so this limit is 3 out of 5. Can you try 46, please? And please let me know when you're done.
Okay.
Yep. And please let me know when you're done. Okay, 36. 46. Okay, how else can this one be done? First things first. I mean, have you ever learned L'Hopital rule?
Yes, I have learned L'Hopital's rule.
Or L'Hopital's rule, okay. Using L'Hopital rule, obviously you have the limit as x approaches 0, and you have the sine of 5x over 3x. 0 to 0, the limit as x approaches 0. Because 0 over 0 differentiate, the derivative of the sine is what? Is cosine, and you have the 5. So you have 5 cosine 5x divided by 3. Okay, and therefore this becomes 5, the cosine of 5 by 0 divided by 3. Cosine 0 is what? Is 1 out of 3. Which is exactly 5 out of 3. 5 out of what? 3.
3.
Okay, yeah, so it's... So these things were just switched around. What did I do here? Okay, this must be 5 and this must be 3. 5, 3, but we switched around. 5, 3, but it means in 3, 5. Why didn't you tell me, actually, huh? Because the 5 is on top, and the 3 is at the bottom. The 5 is on top, the 3 is at the bottom. The 5 is on top, the 3 is at the bottom. The 5 is on top, the 3 is at the bottom. So it is 5 out of 3. I was wondering why now we 5 out of 3 and then 3 out of 5. Okay, right, but it's clear, right? Okay, so this is good news. Let's practice with more problems. Let's practice with more problems. I gave you 46. Please give us the answer to 46. Okay,
I'm
40.
still doing 26.
Oh, okay, that's fine. Please let me know when you're done, okay?
Okay.
Thanks, Atlahan. All right. Right. All right. All right. All right. Please let us know when you're done.
Okay, I'm done.
Okay, what answer did you get there, Atlahan?
0.
Okay, let's check together if this is true. Okay, obviously this question can be done in 1 billion ways. First, I'm going to use the conventional way of doing it. So we first will look at the method that you learned first without using derivatives. And then obviously we shall look at the derivatives like we just did now. So let us look at this particular question together. I mean, what we do here, we have the limit as x approaches 0, which is exactly the sine of pi x. So this approaches 0, which is exactly the sine of x over x, the sine of pi x. So this sort of the way this question can be done, because x cancels x, okay, and we're able to get back to that. But now the limit of a product is the product of the limits, so that here we have exactly out of x, and then we multiply these by the limit as x approaches naught of that. Okay, so as x approaches naught, this one is 1. By definition, the limit of sine x over x is 1. Now come to this one, which is the limit of pi x approaches 0, which is exactly pi x over the sine of pi x. But you would be interested in introducing 1 over pi here. Okay, because this pi and this pi cancel out. This pi and this pi cancel out. Okay, but also as x approaches 0, can multiply this side by pi, but also can multiply this 0 by pi. So as x approaches 0, therefore, this is going to be exactly 1 times 1 over pi. And then this one here is 1 over pi, but you still can write it as pi x approaches 0 of 1 divided by the sine of pi x, which is 1 times 1 over pi, and right, as this approaches 0, this guy is going to be exactly, so you can still be able to write it as 1 divided by, so this limit, you can just take the limit of the top and the bottom if need be, it's necessary. You can still write this one as, let's just put some green color to spice it up a little bit. So we have the limit as pi x approaches 0, and then we have the limit of 1. We have the limit pi x approaches 0, and then we have the sine of pi x over pi x. Okay, so, okay, it's 1 times the top is 1 over pi. The top is 1, the bottom is a 1, and then it's 1 out of pi. So as a consequence, this limit is 1 out of what? 1 out of pi. What did you get? I forgot what you told me. All right, never
0.
mind. Okay, yeah, I remember now. Okay, right, so we can use local rule as well to check, because the two methods are independent, and therefore we expect them to give us like the same answer. So let us practice and see what answer we're getting. Remember that this lesson is recorded, so you'll have the recording, but also the sound does not break when the system records, because the recording is happening right here where I am at the source. Okay. Now, something important is to first take this limit, but now to deal with this limit, we substitute. So we're going to have the sine of 0 divided by the sine of pi 0, and sine 0 is 0, sine pi is 0 is 0. 0 over 0 is indeterminate, called an indeterminate form. Okay, because now we're getting an indeterminate form, what do we do there? Because we're getting an indeterminate form, what do we do with this? Right, so we have the limit. Okay, so this is sort of the 0 over 0 limit form. So we're going to differentiate the top and get cosine x by using local rule. And if you differentiate the sine, you get cosine pi x. By differentiate pi x, you get a pi. And then it is cosine pi x by using the chain rule here of differentiation. But you have to spend a lot of time on the chain rule. In which case, therefore, at this point, you can take the limit again. Have cosine 0 divided by pi cosine pi times 0. And what is cosine 0? It is 1, and this one is also 1. So it's pi times 1, and therefore the answer is 1 over pi. So, I mean, we got 1 over pi before, we're getting 1 over pi now. So indeed, the answer 1 over pi holds true. Please try question 47. And let us know when you're done. Okay? Yeah, try 47 and let us know when you're done. Okay. Right. Awesome questions. Awesome questions. Right. Right. So let us know when you're done, and then we're gonna do it together and see what we're getting. 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 And see what we get. And see what we get. And see what we get. Okay. You're doing 47, is it correct?
Yes, I'm doing 47.
Okay, good. And then obviously we're gonna do it together. After this, we're gonna just see how well you were able to do there. Right, and then we shall have a chance to do these together. Right, we shall have a perfect chance to do these together there. Right, we shall have a perfect chance to do it together. Shall have a perfect chance to do it together.
The answer I got is 3.
You got the answer 3. Well done to you. Okay, 3 is indeed the correct answer. So there are a couple of ways to do this. And one of the ways to do this is to use local rule. And one of the other ways is to use the first year method. The method you learn first before you learn sort of everything else. Let us spend some time right now and do. So we're gonna actually just use one of the methods we've learned to practice these together. So we awesome. Let's look at 47. Right, if you have the limit as t approaches 0 of the sine of these sine t. Right, so what do we get here? Okay, so I mean, you can use Doctor rule because if you substitute, it's going to be like 0 for 0 because the sine of 0 is 0, the sine of 3 times 0 is also 0. So it's 0 for 0, and then you can use Doctor rule to differentiate the sine and get the cosine and multiply, find derivative of the 3t, which becomes a 3 cosine 3t. You divide everything here, and you have here the cosine t, and then it is 3 cosine 3 times 0 divided by cosine 0. Cosine 0, it's a 1 out of 1, which is what? Which is 3. So now, then you have here 3. You have here 3 like that. So any question then here?
No.
Okay, no question. It is 3, but obviously, even if you do it either way, you'll just get the answer 3. All right. Okay, let's get the next one. So now, okay, we continue. Try 48, please.
Okay.
Yeah, and let us know when you're done with 48, and then we're gonna discuss it together. All right, we're gonna discuss it together. We're gonna discuss this together. The 48. We're gonna discuss together 48 and see how well we can do. We do this. And see how well we actually are able to do this one here. And see how well we're able to do this here. See how well you're able to do this here. So yeah. So now you let me know as soon as you're done with this. All right, all right, all right, all right. All right. All right. So let me know when you're done. Let me know when you're done. Let me know when you're done. Right. Okay. How far? You let me know, please.
Finished.
Okay. Okay. All right. Awesome, awesome stuff. Awesome news. And this is awesome, awesome. It's good. Right. So it's an interesting question. We need to practice together. It's an interesting question. We need to practice together. An interesting question. We need to practice together. It's an interesting question. We need to practice together. An interesting question that needs to practice together.
I
Right.
got 0.
Okay, that's fine. Let's see what we're going to get together. So this one here can be done in 1 billion ways, but now we're going to use one of the methods of learn the limits. This one here of the sine squared. Okay, as x approaches 0, as x approaches 0, we have this. Right, you have this. You have this. So now, if you look at this, you can write it as, okay, this actually, you can write it as the sine squared of 3x, and you can put 3x by x here, like this. Just put x first. Then you can have here an x squared. Okay, because this x squared cancels and you still have x there. Okay, now, okay, there are many ways to do it, but yeah, this is a bit tricky. But now you can write this as 9x. 9x squared. As x approaches 0, the limit as x approaches 0 of, can write this one as 3x over 3x all squared like this. Right, obviously you got 0, yeah, that's the answer. Because now you have the limit of 9x, which is like 9 by 0. Right, and then 9 by 0, then you put in open bracket like this, open parenthesis. As x approaches 0, okay, and therefore you have this. Right, so obviously, I mean, what is the limit of the 3x? The limit of the 3x like that, you can put a 3 here like this. So that it becomes, because as x approaches 0, you can multiply this one by 3, but also this one 3 by 0. Okay, so that you have 3x approaches 0, and then you have this, which is 0 times, and you have the sine 3x over 3x, which is 1. And 1 squared is 1 by 0. So yeah, so indeed the limit is 0, either way. But we must indicate that there are too many ways to do this question. Obviously, you can also use other methods to solve the problem, like your Loper rule or Loper's rule, to do this particular problem. And let us spend a bit of time trying to do this one here. Okay. So, okay, now if you look at 48, and then here you have sine squared 3x divided by x. And then now x approaches 0. Okay, now at this point, you substitute straight away sine 0, you square it, it's 0 to 0, in which case, therefore, you can find the derivative of this, which is exactly to the sine of 3x. The derivative of the sine is cosine 3x, and then multiply by 3. You divide by, the derivative of the x is 1. Okay, so now we use the chain rule to find the derivative of this. So it's to the sine of 3 times 0, the cosine of 3 times 0 times 3, and 2 times sine 0 is 0, cosine 0 is 1 times 3, which is exactly 0. So the answer is 0. Any questions so far on this one?
No.
No question. So indeed, the answer is 0 either way. Okay, let's look at the next question. Right, so the next question is this one. Can you try to solve one of the problems? Can you try 49, please?
Okay.
Yeah, and please let us know when you're done.
Yeah.
Mm-hmm. Okay, so you let us know when you're done. Let us know when you're done. When you're done. Okay. Right. Right, so continue. We continue. Right. So please let us. Okay, now I'm done, and then we will notice what exactly we need to do here. You'll see exactly what to do here. All right. We will notice what to do here. We'll notice what to do here.
Okay, I'm done.
Okay, what answer did you get, Atlahang?
0.
0. Okay, that's fine. Let's check. Let's do it together. Right, so up to this pointer, you have exactly this particular question here. And one thing we are able to see is that we have been given the sine x minus sine x. Okay, cosine x, you divide everything by x squared. The limit as x approaches naught, which is sine x 1 minus cosine x divided by x squared. Sine x over x, 1 minus cosine x divided by x. Okay, can write like that because x by x is x squared. Okay, now that is what we can see. That is what is evident. And so at this point, we want to do this, but also want to do this very, very carefully. And we have the following here. What we do, okay, so we can split this limit and have the limit here as x approaches 0 of sine x over x, and here we have the limit as x approaches 0 of 1 minus cosine x divided by x. Okay, so you have 1 plus cosine x divided by 1 plus cosine x, which is the limit as x approaches 0 of sine x over x, which is the limit as x approaches 0. Okay, this one we sort of rationalized here. And because if you substitute straight away, cosine 0 is 1. 1 minus 1 is 0. So it's 0 out of 0. So we need to do something. We just multiply by 1 plus cosine x. 1 plus cosine x is not always that we just use local rule sometimes. So if you multiply, the top is 1 minus cosine squared divided by x into 1 plus cosine x. And this one is 1 times, okay, because this limit of sine x over x is 1. And then you have the limit as x approaches 0, 1 minus cosine squared is actually sine squared x divided by x, 1 plus cosine x. Okay, as x approaches 0 right now, what are we able to achieve at this point exactly? Right, so we actually have exactly this part of the question. And we can take this one to somewhere here. In which case you have 1 times the limit which is which is exactly sine x divided by 1 plus cosine x. That's just one way to do it, because the sine squared is sine x by sine x. Right, so in which case, therefore, we are able to get the answer. What is the answer? So this becomes 1 times the sine x over x as x approaches 0 is 1. And this one here is actually sine 0, which is 0 over 2, which is exactly 0. So the correct answer is 0. And you got a 0 as well. Right, you said 0. Okay, so yeah, we're good. We're good. We're doing very, very well. Right, let's see what else we have here. Can you try 58?
Okay.
Yeah, please let us know when you're done with 58.
Okay.
Or maybe 60. Sorry, 60.
Okay.
Yeah, because I was just thinking which one to do. Okay, yeah, let's try 60, and then you let us know when you're done. Okay, good, thank you. You let us know when you're done. Right. 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 So we're good. Good, 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 good. Good, 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 good. All right. We're good. All right. So yeah, you let us know when you're done. You're doing number 60. Number 60.
English is my second language.
All right. So number 60. Want to see what you're gonna do there? You try number 60. And then you let us know when you're done. Are you able to see number 60?
Yes, I'm able to see.
Okay, thank you. Good. Right, so please just let us to say, now I'm done, and then we can mark. Just want to know what answer you got when you're done. Okay, now, yeah, that is what is important to us. Just let us know what answer you got, and then
I got 1/3.
you got 1/3. I think you're right. Let's just try it together. So you have the limit. Which is exactly sine of x minus 1 divided by x squared by x, which is the limit. Which is x plus 2. Okay, right, so you can write it as the limit as x approaches 1 of the sine of x minus 1 divided by x minus 1 multiplied by the limit as x approaches 1 of 1 divided by x plus 2. And therefore, this is the limit. X minus 1 approaches 0, and this is exactly the sine of x minus 1, and this one is 1 over 1 plus 2. As x approaches 0, x minus 1 approaches 0, so this one is of the form sine theta. Okay, the limit is theta approaches 0 of sine theta over theta, this limit is 1, in which case it is 1 times 1/3 is 1/3. So the answer is 1/3. The answer is 1/3. So that's what you got, right? I think so.
Yes.
Okay, good. Try 53, please, and let us know when you're done.
Okay.
53, yeah. Okay, this one you can also use L'Hopital rule. We can just do it in green, very short. Because a careful look at this shows that 1 minus 1 is 0, and the denominator is 2 minus 2 is 0. So it's of the 0 over 0 form, and this is the limit. So which is cosine of x minus 1, 2x plus 1, which is over 3, and this is 1/3. 1/3. 1/3. Right, so yeah, still 1/3 we got. So you're trying 53, correct? Please try it.
Yes.
Yeah, try 53 and let us know when you're done with it.
Okay.
Yep. And let us know when you're done with it. Right, and let us know when you're done with it. All right. So let us know when you're done with it. Right, so it's awesome. Right, so yeah. Just let us when you're done. So we're doing 53.
Yeah, I'm done. I got 3/4.
You go 3 or 4, let's check it out. So it's a limit as x approaches 0 of the sine of 3x divided by 5x cubed minus 4x. Okay, so look at this limit now. What then are you able to achieve here? Okay, so as x approaches 0 at this point, you substitute straight away and get sine 0, which is 0, and the bottom is this one. It's going to be 0 minus 0, 0. So it is an indeterminate form, and one of the ways we can use to do this one is to quickly factorize. All right, to evade the 0 part, which is sine 3x, over, right, if you pull out x, and then you have 5x squared minus 4 like this. Okay, we just pulled out x from the denominator. This x approaches north, which is sine 3x over x times the limit, which is 1 divided by 5x squared minus 4, which is 1/3 the limit as x approaches 0 of the sine of 3x out of 3x. Okay, let's put a 3 here. So this one here is going to be like a 3 here at the top. So there's a 3 at the top here. Okay, because there's a 3 at the top, this 3 cancels this bottom one. And we have the limits as x approaches north of 1 divided by 5x squared minus 4. And then we have 3 times. And then this one here is exactly 1 times 1 divided by minus 4, which is 3 divided by minus 4. Okay, so this is exactly minus 3 out of 4. It's exactly minus 3 out of 4. Right, so it is minus 3 out of 4. What answer did you get? You also got that one, did you? Yeah?
Yeah.
Okay, that's fine. But now, look, Obviously 0 for 0, can use L'Hopital rule and take the limit as x approaches 0. Right, the derivative of the cos of the sine is the cosine. So, but it's going to be 3 cosine 3x because of the 3x. The derivative of the 3x is 3 divided by, differentiate the bottom, which is 3 by 5, which is actually 15x squared minus 4. As x approaches 0, okay, we substitute again because we just used the L'Hopital rule here. And now this is 3 cosine 3 times 0 divided by 15 squared minus 4, which is 3 divided by minus 4. Okay, so yeah, it's minus 3/4, minus 3/4. We try the next question. Can you try number 50? Please.
Okay.
All right. And then you let me know when you're done with it. Then we just, yeah. Because I want you to exercise so that you're just able to just confirm your ideas. Because you're going to be doing like lots of these kinds of things. Lots of these kinds of questions. Right. Lots of these kinds of questions. So, right, so we have the limit as x approaches 0 for 1 minus secant of x divided by 2x. Like that. Like that, so. Right, so now as x approaches 0. Okay, you let me know when you're done.
Okay.
So that you can see what to do. What to do. Right, we can see exactly what to do. So that you can see what to do. Okay. This is awesome, awesome stuff. Awesome, awesome stuff. Awesome, awesome stuff. Right. Awesome, awesome stuff. Right. Awesome, awesome stuff. How far? Close.
Done. Yes.
Okay. All right, that's okay. Just interested in knowing what answer exactly this is gonna give. Right, want to know the answer to this particular question so that you can decide what to do and make the most of your time. Right, and make the most of our time here. Right, and make the most of our time. Right, so this is awesome, awesome stuff. Awesome, awesome stuff. Awesome, awesome stuff. Awesome, awesome stuff. Awesome, awesome stuff.
I'm done.
You're done.
Oh,
What answer did you get again?
I got 0.
0. That's fine. Let's check together. Okay, now one thing you can be rest assured of is if you substitute as x tends to 0, 2 by 0 in the denominator, it gives us a 0. In the numerator, the second of 0 gives us a 1, and then 1 minus 1 is a 0. So this is like 0 of 0. Because of this, we are at liberty to use L'Hopital rule. Now, if we use L'Hopital rule, we are able to find the derivative of 2x, which is exactly 2. The derivative of the 1 is 0. The derivative of the secant. What do you think the derivative of the secant of x is? What's the derivative of secant of x? Secant of x 10x. Okay, so obviously I have to get to the derivatives. But now as we take the limits, okay, so which is this one here, and which is 1. And then what is the tangent of 0? So the tangent of 0, you can see is sine 0, cosine 0, and sine 0 is a 0 over 1, and this result is a big naught, and the answer is 0 there. You got a 0, yeah? So awesome stuff. So you're able to get this one right, no doubt. There. Let us look at number 51, please.
Okay.
Good. Yeah. Okay. Yeah, we need to do more variety, but yeah, the other questions that are coming that are a little bit different from this. That's a little bit different from this. Okay. So it is most certainly awesome, 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 awesome. This awesome, awesome, awesome stuff. This awesome, awesome, awesome stuff. This awesome, awesome, awesome stuff.
I'm done.
You're done. Okay, what answer did you get?
2.
2. That's okay. Let's check together. So we have the limit as x approaches it. Okay, there are thousands of questions we shall do altogether. And also we shall do past exam questions on this. So now it appears at this point we substitute 0 in the denominator. It's going to be 0. At the top, it's going to be 0. So this is the limit to the secant squared. Okay, because the tangent to x, the derivative of tangent to x is 2 secant squared in terms of the derivatives, and therefore it is 2 the secant squared of actually 2 by 0. Okay, I'm using L'Hopital rule here, differentiate the top and the bottom independently, and the answer becomes 2 by 1, which is 2, so the result is 2 here. Right, so let's try 52, please. But just passing through the questions. And then we shall go to other topics or other parts of this. We shall go to other parts of this. Right, we shall go to other parts of this. Right. So this is awesome, awesome stuff. Right, so we're good. We're good, good, good. Right, please let us know when you're done.
Okay.
All right. 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 Right, so we're good. Right, so we're good. Good, good, good. Right, let us know when you're done.
Okay, I'm done.
You're done. What answer did you get?
0.
Okay. You've mastered these. The top is 0, the bottom is 0. So yeah, because sine 0 is 0, the tangent of 7, 0 is 0. Okay, so now we use Lotto rule. As theta approaches 0, the top becomes cosine theta. 7 the secant squared of 7 theta. As theta approaches 0, it is cosine 0 divided by 7 secant squared of 7 by 0, which is 1 out of 7. So right, we got exactly 1 out of 7 because the secant of 0, 7 by 0, the secant of 0 is 1. It's like cosine 0 because secant of theta is 1 over cosine theta. Okay, so this is going to be 1, and then we're going to have 1 over 7. Okay, so any question on this? Any remark, comment?
No.
Nothing. Okay, let's look at 5.3 we've done. Right, so let's look at 5.4. Okay, try 5.4, please. Let us know when you're done with it.
Okay.
Right, let us know when you're done with it. Let us know when you're done with it. Let us know when you're done with it. Okay. You'll alert us when you're done, please, to say, okay, now I'm done. And
Okay.
then, yeah, we'll see what to do. We'll then see what to do. Then see exactly what to do. See.
I'm done.
Okay, good. What answer did you get?
15.
Like 1-5.
Yes, 1, 5.
Right. Okay, that's okay. All right. Let's see what we're going to get together. We're just practicing. There are tons of questions that are going to do. Okay, if we're doing the limit as x approaches 0 of the sine of 3x times the sine of 5x, you divide everything by x squared. Right, so obviously this is the limit as x approaches 0 of exactly the sine of 3x over x, and we have the limit as x approaches 0 of the sine of 5x over x, like this. Okay, you can break the x squared and you can separate the things like that. Now, at this point, we want this sine to be 3, so we actually multiply here by 3, and you have the limit. Because this one, you can write it as 3x approaches 0, you multiply by 3 both sides. The sine of 3x over 3x, these 3 cancels. At this point, you can put a 5 here times the limit. And then here you can put 5x approaches 0 of 5x over 5x. These 3 times, this one is 1 and this is 5. And 3 by 5 is 15. 1-5, and that's what you got. So yeah, okay, so you really are fast approaching as a superstar. And therefore, this is very important. So as part of our learning, it will be very important to, after our discussion, to give a sense of the types of questions that you think are troubling or the most difficult. And if possible, you can send some pictures on WhatsApp, okay, of the questions. You can send some pictures because I'll always bring lots of questions, but you might have seen a certain type of questions that you think are the most challenging, for example, or are tricky, and we can spend time to do together, even our next meeting, as we even going to spend time on derivatives. 5.5, please try 5.5 and so we can do it together when you're done. Yep. Right, 5.55 that is. I think 5.5, but it's 55. Okay, 55. Right, 55. Right, so 55. Right, and then you let us know when you're done with it. Right, you let us know when you're done. Right, because when you're done, then you're going to discuss it. When you're done, then we're going to discuss it. When it's done, then we're going to discuss it. When we're done, then we're going to discuss it. When we're done, then we'll discuss it. Done, then going to discuss it. Right. How far? It's 55. All right, fine, thanks. Okay. We are doing 55, 55, 55. 55. Right. 55. Right, 55. 55. Right, right. 55. Right, so let us know when you're done.
Okay.
Okay. Right. Right, so that we can see what to do. Can see what other topics, other parts we need to discuss. Right. Right. Right, 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 right. Right, right. So we're good. We're good. Right, I hope you're finishing. 55. Okay, we're practicing together, but I'm just interested in seeing how well you can actually be able to do, but also testing your ability to tackle questions as we go along and try.
I'm
Yep.
done.
Okay, what answer did you get here?
Positive infinite.
It's infinity. Never mind. Okay, that's fine. Okay, let's see what we're getting together because I've never done this question before, but I'm hoping that if we use the correct mathematical laws, we shall be able to get the answer. I've taken these from the textbook. Okay. Right, so now what we're able to see as theta approaches zero, it's going to be sine zero, which is 0 at the top, and 0 plus 10, 0, which is 0. So it's like 0 to 0, giving us the limit. This is as theta approaches 0. What is the derivative of sine theta? Cosine theta. The derivative of theta is 1, and the derivative of the tangent of theta is the secant squared of theta. Okay, I'm just using L'Hopital rule. Okay, so that at this point we have exactly cosine 0, sec squared 0, 1 over 1 plus 1, which is 1 over 2. Okay, we're getting 1/2. Right, your take on this one? No question. Is it okay? Or anything that you would like us to change?
No, it's okay.
It's okay. All right, that's fine. 56 is next. Just giving you like 2 minutes to try 56. All right, 2 minutes to try 56. 2 minutes to try 56. 2 minutes to try 56. Two minutes to try 56. Two minutes to try 56.
I'm done.
Okay, what answer did you get?
Infinity, positive infinity.
Okay, it's like infinity is becoming more popular, but yeah, there are a lot of questions on infinity that are just going to be coming. So obviously we have the limit as x approaches 0 of the cosecant of x, which is the sine x. Okay, so if the limit as x approaches 0, 1 divided by sine x, sine x here. Right, so this you can write as the limit is sine x approaches 0 of the sine of sine x divided by sine x. Okay, what we're able to see here is a sine x approaches 0, then this limit is like the limit as theta approaches 0 of sine theta over theta, which gives us a 1. So clearly this limit here becomes 1. Okay, any question or anything that you'd like us to do? Because once again, this limit is the same as the limit of sine theta over theta. Theta approaches 0, and obviously here, what we have in here is we have exactly the limit. Okay, where sine theta itself is the sine of x. So obviously, I mean, sine theta over theta, theta approaches 0, this limit is 1. So this is 1 in the end, getting a 1 altogether. Okay, now the couple of questions we're going to do. Let me try other questions. Can you try 57? Okay, let me give you a chance and a different question, please. Okay, let us try some questions that are like different and see what we can do. And see what we can do. Can you try number 14?
Okay.
Yeah, so something different. We've done lots of the trig questions, trigonometric functions. So let us try this one, number 14. And yeah, what time is your meeting, your class, your business after this? What time is it? What time am I supposed to be at your new
Quarter to
spot?
3.
At quarter to 3, eh?
Mhm.
All right, so we're good. Yeah, okay, it's fine. Right, because we're going to be finishing at 2. So yeah, we're going to have the time too. Right, yeah, we're trying with number 14. Please let us know when you're done with number 14. Right, so please try number 14. Try number 14. Right, try number 14. Right. Try number 14. Try number 14. Right. Try number 14. Try number 14. And please let us know when you're done.
Okay.
Right.
I'm done. Got
What?
-1/2.
Okay, let's check together. Okay, I'm just giving you number 14 because there's infinity in it. And of late, you're like giving lots of answers with infinity. Okay, so obviously we have the limit as x approaches minus infinity, and then we have the square root of x squared minus 9, and you have 2x minus 6. Okay, so obviously one thing we can notice is if we just substitute the infinity straight away, it's going to be 2 times minus infinity, which is minus infinity minus 6, giving minus infinity in the denominator. And in the top, you square minus infinity, getting infinity. You take the square root of infinity, becomes infinity. And this infinity out of infinity is actually what we call an indeterminate form. Right, indeterminate form. But as a consequence, then if you take the limit as this x approaches minus infinity, then whatever we're getting is the following. Right, so we need to obviously take the limits as x approaches minus infinity. Pull out x squared. 1 minus 9 over x squared divided by x. 6 over x. Okay, which is the full x squared. 1 minus 9 over x squared, which is x. 2 here. Okay, pull out the x here, it's going to be like 2. And this is going to be like 2, so you have a 2 here. And then you have 2, 6 out of x. Okay, so obviously at this point, you have the limit as x approaches minus infinity. And this is exactly the square root of 1 minus 9 over x squared, which is x divided by 2 minus 6 over x. Right, as x approaches minus infinity, the absolute value of a negative number is going to be minus x. 1 minus 9 over x squared divided by x, 2 minus 6 over x squared. X cancels. This is the limit as x approaches minus infinity, which is 1. Okay, we are finishing. 1 divided by 1 minus 9 out of x squared. We divide by x. Okay, the x cancels, so that we have exactly 2 minus 6 out of x squared in the denominator. So we'd have the limit as x approaches minus infinity. So the x cancels here at this point. Just remove this one here so that somebody's going to be seeing this and saying it's not complete. Okay, so obviously we have this here and x cancels, giving minus the square root. 1 minus 9 over x squared. You divide everything by 2 minus 6 over x squared. Okay. How's this? Which is 1 minus 0, 2 minus 0. You got minus 1/2, right?
Yes.
That is so good. Can try number 10.
Okay.
Right, and let us know when you're done. Right. Right, so we're good.
I got the answer.
What answer did you get?
Positive infinity.
Okay. The infinity symbol is appearing very often. We're finishing just now, okay. Listen, we're just sitting here a little bit. So we're 4 minus v divided by the modulus of 4 minus v. Okay, as v approaches 4 from the right, imagine a number bigger than 4, like 5 or 6, and the difference becomes a minus 2, which is negative. Obviously, if ever we have a negative that comes as a result of the absolute value, the result becomes negative. Okay, because the modulus of x becomes x or minus x. It becomes x if x is negative, or x if x is positive, or 0. Right, so obviously it's a positive side here. But now the bigger numbers, 4 minus bigger numbers is going to be negative, so you put a negative there. And you cancel out, and therefore this guy cancels out. So you can have that kind of thing. So if you have this cancellation, you have this cancels out and becomes the limit as v approaches 4 from the right. So the answer is -1. The answer is exactly -1. Can you try number 17? Number 17 is the limit as x approaches infinity of the square root of x squared plus 4x plus 1 minus x. Okay, so, right, please let us know when you're done.
Okay.
Right. All right. Right, see what we can get out of this. Right, let's see what we can get out of this. Right, do let us know when you're done. Let us know when you're done. Right. So please let us know when you're done.
I'm done.
What answer did you get?
0.
Okay. Right, okay, if you substitute straight away, every time we just substitute, so you'd have infinity squared, which is infinity, plus 4 times infinity, which is infinity, plus 1, which is infinity. The square root of infinity is infinity. So you have infinity minus infinity. But this one here is indeterminate. Right, so it is indeterminate. It's called an indeterminate form. Okay, because it is indeterminate, what do? We rationalize. So with the limit as x approaches infinity, and then we'd have the square root of x squared plus 4x plus 1 minus x. If you multiply by the square root of x squared plus 4x plus 1 plus x divided by the square root of x squared plus 4x plus 1. So that in the end, we multiply this with that, which is x squared plus 4x plus 1 minus x squared divided by x squared plus 4x plus 1. Okay, so the x squared cancels out, which is 4x plus 1. Okay, so you get to this point. When you get to this point right now, you need to just perform some factorization. So this is becomes the limit as x approaches infinity. Okay, you can write 4x plus 1 in the numerator like this. In the denominator, you can take out x squared, whose square root becomes the modulus of x. And this becomes 1 plus 4 over x plus 1 out of x squared. One out of x squared, like this. Okay, so this is exactly plus x. So in the end, then what we're then having here is the limit as x approaches infinity. Right, and then we have 4x, you divide by, okay, as x approaches infinity, the modulus of a positive number is just x. If x is positive as x approaches infinity, which is 1 plus 4 over x plus 1 over x squared. So in the end, you pull out x, which is the limit. So, right, so x approaches infinity, which is 4x divided by, which is 1 plus 4 over x plus 1 over x squared plus 1. X cancels out, giving us the limit as x approaches infinity. So this is like 4 divided by the square root because the x cancels. 1 plus 4 out of x. 1 out of x squared plus 1. As x approaches infinity, which is 4 divided by the square root of 1 plus 0 plus 0 plus 1. Like this, which is exactly, I need to write a little bit. So this is going to be 0, 0. When divided by infinity, it's going to be 0, 0, leaving us with exactly 4 in the numerator, divided by 2, and 4 divided by 2 is 2. So the answer is 2. Okay, the answer is 2. Okay, so this limit here is actually 2, number 17. Now, I'm giving you a homework because we're going to meet again tomorrow. But I'm giving you homework. You try the rest of the questions we did not do. Like, you must do this one here, this, you do this, you do that, you do this, you do that, you do this one, that one. Let's see. Okay. Right. This one we did apparently. You try this one as well. You try this one, you try this one, and you try this one. Everything else, with the exception of the ones we did like, yeah, I think we did, if I remember well, we did number 14. But yeah, these will sort of be your homework. You do the ones you can. I'm not saying break your fingers and exhaust yourself. That's not what I'm saying. The ones you can do, even if you're able to do 2 or 3 of the questions, it's enough. Okay, because that's what we're gonna start tomorrow. The rest we're gonna discuss on WhatsApp. But we must thank you for joining us. It was awesome having a discussion with you today. It was our first lesson on calculus. Yeah, I'll see you again tomorrow. Okay.
Thank you.
Thanks a lot. Enjoy your day and enjoy. We'll talk again on WhatsApp. Okay. Thanks, then, and goodbye.
Yes, you too.
Goodbye.
Bye.
Mhm.